Okay, welcome everyone to Cloud Computing and Big Data today. The topic of today's lecture is Lecture 13, OpenStack Cloud Operating System. And it's a very interesting lecture, not only because it's a final full lecture, it's also the idea of thinking about shifting the view. While you have been using in this course Amazon Web Services, Microsoft Azure, or the Google Cloud Platform, or even Google Collaboratory, this is now an idea of shifting the view of where you are responsible for operating a cloud. So what happens if your boss comes into your door and says, it's nice that you program a lot and that you code a lot, but actually you want to have a private cloud in our company? Do that. So your first question is, can we learn something from the big public cloud providers? And is there something outside which already has done such a thing? And then you quickly come to this interesting OpenStack cloud stack. And it's a really large stack, so I really could do a complete lecture series around OpenStack and their certifications of all kinds of different services. So we shed light on a couple of interesting ones and always compare it a little bit with what you learned in the public cloud, and then how you can implement essentially the same functionality within your company, organization, and so forth. But before we go that way, let us just briefly review what we did in Lecture 12 last time. The last lecture was really focusing on containers, and the idea of the analogy that you see there in the ship, that basically have a transport mechanism of containers, and the containers are inherent consistent. So they would have everything what you need inside. So of course, in the real world, it's maybe all what you have in terms of housing when you move to Iceland. On the other hand, of course, in software engineering and software development, that means you have the right binaries, you have the right libraries in place. Everything your application that you implement, that you develop, that you deploy on a cluster is actually inside this interesting container. And when you do so, we have seen the comparison essentially when you compare it perhaps with virtual machines, which in a way we thought was doing the same thing. Some people talk about this, by the way, of talking about application sandboxing. So everything is in the play sandbox, so to speak, for the application to play around. And we see essentially virtual machines can do the same thing. They provide a consistent runtime environment. But what the difference here on the container approach is not only it has a much more smaller size on disk, you see that a little bit illustrated here, because essentially we don't carry around anymore any guest operating system. It has also relatively low overhead, leading to a couple of things. One of it is, for instance, that you may not necessarily always have to install all the software in this and that version, but you just rather write an instruction of pull always from repositories the most, let's say, up-to-date version, or the version in a specific, the specific version your application needs. And with this, it becomes automated. So you have really an automation of the process where you have Docker as, let's say, in the moment, kind of a de facto standard, I would say, in containers. You have also learned that Singularity is another one at the end of the last lecture, which is much more openly deployed in HPC environments, having there a couple of benefits, but it's still, let's say, work together with Docker. And this offers lots of opportunities. And of course, we have said this is just one end of the story. So in the end, when we are in this ship that you see there on the top left, we're kind of lost. So where is my container and how it relates possibly to other containers? So apparently we need someone here on the bridge on the ship that has an idea what all of these containers are doing. Especially if you want to do more than one and they all, let's say, should interact together to achieve some common goal. And one of the ideas where we said was interesting to do was, of course, MapReduce, right? You think about some should be in the Docker container, the name nodes, and some maybe in the Docker container, rather the data nodes. They have different operations, maybe even different libraries required. So how that works together. And this immediately brought us to the challenge that we need some automated rollout process, especially if you think about that, the applications you do in a development cycle might have different versions, or require over time different binaries and libraries that are going to changing. You have production deployment that you face to your customers, or you have some of them which are just for a developer team. So you go on, and your complexity will actually just explode. You have lots of different types of nodes, maybe master worker nodes, as you have in MapReduce. You have then health monitoring required. So is there actually the name node down? You remember this was quite a central one. If that's down, then the MapReduce doesn't make more sense anymore to use. And then we have also seen that in many applications, and we pick on one again today, which is a very good example from Blizzard Entertainment that some of you will know from the gaming industry. Of course, I want to scale, right? And this is exactly another point or a key feature where Kubernetes came in. So Kubernetes with kubelets and working nicely together with Docker is essentially the entity here on the bridge, someone who has an overview about all what's happening in these containers if they interact. And there are different examples we did last time where you define then these nodes, and we have seen that Google is doing this. You basically manage it, the whole situation in a kind of declarative way. You declare what is running with what version, and you can actually then, as one of the key benefits we learned, ship this container around. Right. So again, the migration, of course, of these cloud containers is now, of course, a very nice property. We have seen, for instance, here in the Advania cloud with the UberCloud example with the HPC containers, that by using Kubernetes and Docker, you can deploy on Amazon, Microsoft Azure, HPE, Google Cloud, you name it. Today, we will learn that even Kubernetes will interface with OpenStack, so you can actually deploy it in your own private cloud. And by doing so, you have, of course, now a little bit of flexibility that we didn't really had so much before discussed in the course. Now you have vendor freedom in a sense. If you are doing things right, you base on Docker and Kubernetes, in a way, you're a little bit independent from the real big cloud providers. And with this can, of course, migrate to another cloud if necessary. There could be, for instance, costs which are getting too big or things like that. Now, the interesting thing we also learned is, of course, as this is interestingly enough everywhere supported by orders of magnitude in these clouds today, there are also lots of service environments around it. And the second lecture part last time was really then focusing on the different pieces which are very special. One example was then that the registry, the container work based on this, where you can store your Docker images for an applications is specifically supported for Google, but you can see that they have also interesting services which makes it a bit unique for supporting the whole development process. So it's not only about the finished software that goes to the market and that is updated and maintained. This whole process I'm talking about, the whole life cycle of having software development and then actually launching it in the cloud. And then, of course, on top, what we want is to have it as a containerized application to be scalable, right? And all this automated process is where Kubernetes helps. And the different others we discussed, one example was the deep learning containers, which are actually also used here. You see in this interesting example, we have this cookpad. Also there, handling with peak usage of the app during the TV show. There's an associated TV show that introduces the app. Then suddenly, of course, you have people looking this TV show and all download suddenly the app and use it. So before there was a different load. So you have to scale with this load in an instant. And I mean, the numbers here, working with deep learning with 12 million images and more, and 140,000 users and more already is something where a small startup would be already, let's say, with a small server somewhere downstairs in the cellar, quite overwhelmed with. So using the cloud for these purposes, of course, is a very good idea, always thinking about that the scalability is really a key element of the clouds, where we come back to also as part of today's lecture. And then basically we continue with a couple of examples, and I brought the UberCloud example because I think it's a very good example how, for instance, small startups can still find a very good niche market in the cloud business. We have seen that the UberCloud essentially focused on computer-aided engineering, computational fluid dynamics. We see here a typical problem in that area using the ANSYS package, which is a commercial package, but still very useful for aerodynamics, creating airplane parts, or as you see here, an example using the wind turbine aerodynamics. And of course, this is now the interesting fact that if you use this UberCloud HPC containers based on Kubernetes and Docker, you essentially can deploy it in Advania, but you can also go essentially to Amazon or Google Cloud as we discussed. And now what we will today will actually learn, and this lecture today will actually come back to this one. We think you have your application somewhere, you have Kubernetes, you actually declare everything you need in this environment. But then you can go to Google, to any other cloud, which means maybe Amazon, but of course your own data center as well. And this is where we talk about, and which we didn't previously talked about in terms of software. We discussed several metrics for scalability already very early in the course from a user perspective, but of course the matrix in a way, if you are providing, if you are the data center, you are the host, then these metrics also matter to you as basically a judgment how good you are in your job. And we will come back to this and see that also there are some components in OpenStack that actually can support you in this. So, as I said, we're going toward the end of the lecture series. This will be the last of the really full content lecture. Next week, we will have online social networking and big data streaming tools, both more as a pointer to really large other areas in this field. So graph databases would require a really complete university lecture, a university course, right? We cannot get that just in one university lecture. The same is true with big data streaming. So essentially, streaming is a huge field these days. You need a whole university course for that. But we shed some light and give some pointers before we then finish the course next week with the epilogue, much more concentrating now on our exam because that's in front of our door and we want to be prepared. So with this, basically we fulfill, as you can imagine, a lot of promises. We always were pointing to this technology already early on in lecture 1 of saying what happens when we our own want to create a cloud. When we said in lecture 4, looking a little bit on virtualization, how is that really supported? If I have to do this at scale, then maybe I have to do something that goes beyond the typical VMware or Zen and the others that are around. We looked in it in MapReduce and machine learning environments and said, okay, there's some special software around. And finally, then also thinking about the association rule mining and the container. So in one way or another, the whole course is indirectly or directly related to it. And we will look on this, of course, again with a, let's say, firstly, a little bit abstract point of view, coming back to our scalability challenges that we always have. When we do cloud computing, we will look at certain metrics which are important to think about from both perspectives, user and provider. Because now what I said, we will take the position of a provider today, right, in this lecture. That means we want to build our own cloud using landscape services all over in OpenStack, and you will see it's a plethora of services that you can use to really have the basic building blocks for your own cloud already there. You essentially just need configuration with different entities. And then we will really compare again. In a way, we look back to many of the course aspects we already had. We look into the AWS cloud that you already used, and we'll basically put it in context what it would mean for us to create a private and hybrid cloud with the same building blocks. We will have this for terms of compute and of course then also for containers that we learned recently, but also for storage. And we learned already essentially in AWS that different types of storages, so object storage, block storage, or this elastic file system, if you remember in AWS. Of course, also OpenStack here provides the key building blocks to do similar things. In the second part, then, we continue to look at advanced functionalities, and this would mean I could talk again a complete university course on that. But essentially here I pick several different pieces which I think are really essential to understand, which is the scaling again, about sample configurations that you can easily use for having a normal application supported by your own private cloud. Then essentially a little bit about APIs and SDKs, but I put more emphasis on really the business cases again, which are the adoptions of OpenStack. And you will learn it's actually quite broadly adopted It's massively used, and I think a good example is e-commerce at eBay, Blizzard Entertainment. These are names which are really large enterprises these days. So even though these companies, they not only adopt it, they drive the development, they actually contribute to developments here and there, because the funny and interesting things with that is it is open source, right? OpenStack is free available, which means every single little SME can take this and then create their own offering or their own basically private cloud. And this brings us a little bit to an example where this is also adopted in the academic field. So it's not only for business. You will see that even the academic field is now having lots of different clouds in US, in Germany here as the example, that adopt OpenStack for their own private cloud. And I will make an example and also basically put it in context of your assignment, because you're actually using the Helmholtz Data Federation in one of the assignment parts. So fasten your seatbelt for the long list of very many different names for services. So let's start with OpenStack by motivating it again a little bit. So why we need something like this, right? So in a way, we have already Amazon, we have already Google Cloud. You see that here we have Kubernetes nicely, so we even can switch between those. I'm not actually stuck in the Google Cloud platform. I can maybe go to Amazon, just put there my Kubernetes, and then with this the containers on. But in a sense, you have sometimes sensitive data, right? And this is something what you perhaps not want to put on the public cloud. And this is just one example. The Blizzard game servers, which are really key hard to the basically the company, right? This is another example which we will allude to later. So there are different reasons why people want to have, let's say, still their own data centers. And even if this sometimes is perhaps more costly than putting it in a real open cloud, the, let's say, security requirements today and security may really justify that money, and then it's a good investment. Of course, there's a break-even point at some point in time where you maybe can consider a hybrid cloud approach, which essentially you see here, right? And making it private here, and you can just, combine these models which are public, you automatically create essentially a hybrid cloud by using open interfaces that these cloud, of course, also provides. An example would be putting some of your data, which is, let's say, not so sensitive, in the public cloud on AWS using S3, as you remember, the S3 interface, or the Glacier even, which was more for archiving. So this could be documents that you may require anytime in the future, but it's not really sensitive, it's not important, you just store it there. And there we have seen the costs are almost 0.000. So maybe an interesting cost advantage instead of putting it in your data center running on active disks. Because what these large cloud providers, of course, can do, they immediately have tape archives. So tapes are very slow, but extremely cheap in compared to capacity to active running disks. And with this, they could deliver a very good price performance ratio, of course, in that area. So by motivating this, we can go to the next idea of thinking about when we think about cloud computing. We learned a lot now in the course about virtualized resources and data centers, but the key challenge is this horizontal scalability. In the end, the scalability metrics that we have to fulfill for our customers. So this was a key concern we already had early on when we thought about what virtualization brings us. And OpenStack really has it inherent in the design. So, and you see it very successfully because it's the most widely deployed open source cloud software in the world. You would be amazed when you look on the website how many people really adopt this and how many really contribute to these activities. There are whole conferences just for OpenStack these days. And it's an interesting technology which we will look in. But remember, when I talk now about it, I really cannot talk about everything. I picked some different pieces. So again, some parts and key elements about OpenStack. It's one of the top 3 most active open source projects. That's also interesting if you think and be a software developer. This is probably not even any more true today. We are, I think, at 20 million plus. So this is getting so quickly updated. So it has lots of compute cores, which it has control over in the sense, of course. Control means you have still, as an owner, the full control, but they're running OpenStack. And it has lots of different interesting functionality. One of it is to keep the overview with an attractive dashboard. And another one, which is really a key example we go in later, are these sample configurations. So for lots of different real world problems, you have already a setup how to create your cloud. Other people would say it is a blueprint, example configurations of different OpenStack services to put together. Again, similar, maybe perhaps a bit like Lego, right? Putting that together in the different pieces in order to solve a real world problem. And on top of it, you can get help. There's lots of OpenStack marketplace solutions around. This goes from existing clouds that you can join, and private and public ones, up to training, consulting, and of course appliances. So how basically people have, for different purposes, already set up a cloud, and you can actually download this and reuse it. The key areas, of course, you can imagine now being long enough in this course, is around computing, networking, and storage. But it has lots of shared services as well. Of course, still the hardware means something, right? So you cannot imagine that running OpenStack doesn't require hardware, of course, right? You have to have hardware for this to do it. But the interesting thing with OpenStack is once you have the hardware, you don't really have to implement software anymore to create a cloud. Essentially, with a dashboard, you can tune it, you can make it look and feel that this is your application cloud or private cloud of the company by using all the different components which are in the OpenStack service portfolio. And this doesn't mean we can, just specific things. You will see it has a broad service portfolio. We can handle bare metal, virtual machines, or what we last time learned about the containers. And this is just essentially looking on compute. So it's really an interesting technology, a very lively technology, I have to say. So I have rarely seen such an open source project being so lively. Hadoop for a certain period of time was that when it came out, but OpenStack really tops that significantly by having major adopters from industry. Again, you see here a couple of them I want to highlight here today is Blizzard. Walmart in terms of retail shopping is using it. You see it's all over the world. China is using it. So OpenStack is really, interestingly enough, all over the business adopted. And you see here the fact that it's already 20 million plus cores, right? Not anymore 15 million cores. Now, the other interesting thing is that academics and business pull on the same strings here. So also the academic areas, when they have to create, let's say, their own clouds for a specific purpose, let it be here for our example for research and teaching, right? Then we basically have here also the opportunity in academical scenarios to really adopt all of this instead of just reinventing the wheel and essentially just redeveloping everything because it's open source. So it's a very beautiful example where, let's say, research also now benefits from business in one way or another by having, of course, these components also integrated in the landscape in research and can do a lot of good things, which we will see towards the end of the lecture. So we'll focus first on the functionality, really what OpenStack can do before we go into these adoption scenarios later on. So let us just go quickly through the matrix because we already talked what they are in another lecture, in lecture 4. You remember it was the scalability matrix that we have to deal with peaks, so add and remove processors all the time, right? This is for games important, but also for business as well as in research when you have, load before a high conference, high attendance conference where people do their runs. So this is all over the place. You have software scalability, of course. This should be scaling up to new tools, new compilers, new GPU versions, which have then the right libraries that they actually can be used with it. So this means certain software scalability goes with it. And we also learned that in a way, the application in itself needs to scale as well. So an example might be then using MapReduce. Of course, when we have a big, let's say, load on the MapReduce, it doesn't make sense to deploy just 2 workers. But if the application is hard-coded towards these 2 workers, and 1 master, 1 worker, then it will not work. So you have to also think about that, of course, the application has to bring certain scalability with it. So if you have more and more data, that automatically somehow you'll be able in the application to get the, let's say, data in parallel distributed to different worker nodes, as the example of MapReduce. And then the technology scalability is now the other side from software scalability, in a way when you think hardware is reinventing itself every couple of years. We see the GPU generations now, which have a massive impact, a massive pace. Basically outside was A100, before V100, P100, going back to Kepler. So this was an enormous pace if you think about from traditional computer science perspective is. And of course, the clouds has to scale up with the technologies. And also here, OpenStack provides several services which we can use for these elements to really have, let's say, different deployments maybe of your applications on different generations of GPUs. And that is all essentially nicely possible with OpenStack and the whole cloud service stack. And now this is a really full-blown slide. I think now you can see why I said in the beginning, so make yourself ready for lots of different names. And of course, in the exam and assignments, I don't want to know, let's say, each of these different ones, right? I don't want to know what Sahara is or Solum, but there are a couple of them like Nova, which almost in every one OpenStack implementation adoption is included. These days, containers getting a little bit more interesting. So I picked a couple of them, which of course are for us a little bit good to learn, to know, because they carry along essential, really essential functionality. Also, we will see that Blizzard is working with Heat and Zenlin for doing orchestration and auto-scaling. We will have, of course, the network perspective shortly when we think about security in networks, when you have MapReduce. Or, as you can imagine, storage, cloud would be nothing if you don't have storage, just compute would be a little bit tough. So we look also on these ones. With this goes a huge ecosystem that you see around here. So you see container-specific services. You see essentially interesting, nice UI elements and APIs for EC2, if you remember, to the AWS. You have different monitoring services. Of course, you know what that means, billing. So if you want to really get used with the cloud and offer it, maybe not with a private cloud setup, but with a public cloud setup to other users, you want to bill it. Things like that. So this is a huge portfolio. And my assumption would be now, it's not really proved, but I would say, if you are having a cloud problem and you want to develop your own cloud, I would say all is there in the cloud that you need from the essential functionality. Of course, your unique selling proposition, what you exactly do, you have to implement. But the software pieces that you here see are able to cope with almost all the problems you have in a cloud today. So in this sense, before you go and reinvent the wheel and develop your own auto-scaling techniques, just have a look at Heat, or better even Zenlin these days. Before you want to deal with virtual machines and containers on your own, think about how you rather can, put Nova as a basic service and then put things inside, like Jupyter, for instance, some of the things we do later on with the Helmholtz data federation. So again, by re-emphasize here for the exam, you don't need to learn now all of these names alone by heart. I just pick a couple of them, which are also then in yellow blocks, which I highlight, particularly making a case for it, which are here to learn. Of course, it is interesting for us that it's not only the cloud per se in OpenStack, it also shows you directly here, essentially, also the lifecycle management is supported. And let's go a little bit through a couple of them that you already know. The infrastructure as a service, public cloud. You know that by heart now, the EC2. So we want to have a compute entity that scales, right? And this is possible with this OpenStack Nova service, which has a couple of components here, really. A conductor that is, a little bit looking on all the requests and initiating build up, build down, resize requests to make it elastic, right? To scale, again, horizontally and so on, based, of course, on the hypervisor and VM technology that we learned. A scheduler that has to know, of course, where you place which tasks that come from your API or basically indirectly, and then via the conductor, of course, forwarded. We have a Keystone as identity. We have here Cinder storage and so on. You can go on and basically very much in the details. Neutron is here the networking service. Of course, it's related, but here you have already some blueprint really of creating your own cloud just with the components you have from Nova, but then also directly nicely interconnecting to other essential services we will have a look on. And so this is basically used in different clouds today. I used it with the Volkswagen Group once in one of the lecture, which actually create a hybrid cloud where you can on the one hand use things like AWS, but also Volkswagen has their own OpenStack based one. If you know about automobile industry, if they basically have new designs of models, they rarely would like to give that directly to the cloud, to the public cloud, in case there's some security incident. So they keep these design aspects rather all basically very much secret of the new car manufactured model. Just one example. And when we now go and think about, okay, well, that's boring. We'd had this at the beginning of the course of virtualization. Yes, the last time you told us we actually should go for containers. Of course, there's also Zun there available, which implements everything we just had refreshed at the beginning of the course, so I don't go into much detail in that. But you can imagine that this Zun service is now exactly doing what we actually have described, so it can actually pull containers from Docker into a compute environment that you see here. It has all the necessary functionality to put Docker in a computerized environment. And you see here, a glance is an image service to pull those, and a specific container service that says, of course, where this Docker is, this particular container image, which reflects a little bit work you have to do on the network. So there's also, let's say, helper container services even, that is not the container service in itself, of course, but some that really connect you to a very flexible setup to look where you actually then deploy these containers, because as we learned, it's very dynamic. So you cannot have a hard-coded, so to speak, network environment. It needs to be software, managed. So these are two examples. Then, of course, you can go to the other side of the equation. That was computing. We learned in our lectures before. It's now also almost getting for you a little bit boring, I guess. That's why it's good that we're at the end of this lecture series. I think you learned a lot already. Bucket stores, these object stores are just incredibly useful today. Let it be MapReduce, putting key value pairs inside, or what we did in our assignments partly. So it is essentially a very nice, attractive way of doing storage today, just thinking about metadata, not anymore directly about a file system anymore. In this sense, very attractive. We have learned about block storage, which you essentially just can attach, as you see here, to one of the compute devices, basically mimicking, again, raw data blocks that you have on a hard disks. And it's not anymore like an object storage. So in a sense, you really have an application directly grip on it, and it needs to be basically persistent somewhere, used still with some compute engine, of course. But another way of having storage, so it's also often used, of course, in a way the normal hard disk idea. And then the file system that we had here, which was a little bit different, thinking really clearly just about files in a very traditional sense of directories, links, and files, and so on. So this is, of course, another one where we're used to, and which is also for that reason used incredibly often today. Again, as a summary, you see essentially a little bit that here. I don't go too much to data transfer, but of course also this is supported. Now, how that reflects now to OpenStack, because AWS services you have known now. So you see here again, basically the three key services that mapping this behavior or this functionality that you just have seen in the AWS services. So if you have a Swift service, you can actually do the very same thing. You provide object storage in a distributed system setup, which is quite nice. And doing things like this that really are scaling out, right? Thinking about storing photos on Facebook as a use case, retrieving songs on Spotify, right? So this is things where you need up and down scaling depending on the load of people using the technology. If you want to do, let's say that we once had said the Nordic Light upload download service, which you charge for other people that are using your service, then this would be a way to go perhaps. Then for other applications where it's a little bit more API oriented and a little bit more on looking from the application perspective directly how I use it, you basically can have block storage. And here it's important that you understand the difference, right, between these two, where object is usually here located via data, metadata, and has somehow a unique identifier to find it. So we don't care about file anymore, right? While the block storage has somewhere raw blocks, data really on a hard drive. Some block is controlled like a hard drive. And this is really a key difference that might be also very important for an exam, for instance, to understand. So because we're already at the end of the first lecture, I think in a way you could see that I could go now on and go through the whole website and give you all the different services, but that's not the idea of a university course. You can do that on your own. I think much more interesting is to see that and point you to this, because it could be very well the case that in future, at least more and more development teams will adopt OpenStack in their own cloud setups within the company to be also, let's say, more comparable to those outside, to link perhaps in peak times to the outside world with AWS or MS Azure for certain things. And in this scale you're really talking about, today of data, we see that even small, medium enterprises are already getting lots of requests, having large data sets to process. With this, you need some, dynamic users which are actually able to use your product nicely. And for this, you need this kind of scale out infrastructure. And this is a nice video to explain again why OpenStack then is useful for you, because otherwise you have to all do that by yourself. There's no doubt that developer can do this, smart developers, but here's already lots of different elements thought together as one frame of reference or blueprint that you really can nicely use to create your own cloud. So in this, I think we stop here for 10 minutes and then we continue with the second part of today.